Okay, so our session is about the effectiveness of problem-based learning as a strategy for to foster engineering innovation and critical reasoning skills for students. Okay. First of all, let me just ask you a quick question. Raise your hand up if you heard about problem-based learning, or if you have done any PBL project before. You have not, that's fine. This is what we are going to learn about today. Okay, all right. Okay, that's good. Okay. First of all, let's define an engineer. An engineer can be defined by his or her responsibility. It is the great responsibility of the engineer compared to men or women from other profession is that his work or her work are out in the open. Everyone can see them and can see their work. So they have great challenge. Okay. Also, and they can see also the acts that he's doing, or he has to make sure that he is acting step by step and following scientific reasoning. Okay, so these are all characteristics of an engineer. We're not going to spend more time on this, but one of the important one that he cannot do things without being responsible for it. Okay. Now, why we need problem-based learning? I mean, why don't we just use the traditional method of face-to-face, where the lecturer is on the stage and giving the presentation to the students? This is because we have now a new generation of students. Okay, the millennial students have grown up and now they are the university students. They are now our generation of university students. These are our millennial students, and millennial students, we need to deal with them. We need to teach them or change the learning method to adopt what they like, what they are interested in. Okay. Of course, you know the generations and the way they adapt to internet and to social media and to using the applications and mobile applications. The first generation did not have any internet skills because simply there was no internet. So it was called, like we can call it 0G or generation 0. Then we have generation 1, 2, generation 3, generation 4, and now we have the 5th generation of networking, where here the internet, the telecom internet is very fast, and they can reach into very high speeds that you can deliver a multimedia with less than with a blink of an eye. You can download or you like a multimedia. So we have to adapt to these advances in technology. Okay, and this is what our millennial students are used to, or they opt to, or they are looking forward to find in their colleges these kind of technologies. This is just again some statistics about the network or the infrastructure that was there. Before the 80s, we had the first generation of telecom and networking. It was only voice, only services, the mobiles. The second generation till 2000, or maybe just before 2000, we have voice and data services, and you can reach up to 14.4 kilobits per second. And this is, by the way, not very far away. This is just in the 1990s, okay? I know maybe it's before most of you were born, but it's not really a very long time ago. Now, then we had the second, the 2.5 generation. Here we have higher speed. We started to have some web mobile internet, although there we had a low speed streaming services, but it started to appear. With the 3G, which was like in the 2004, 2005, we had voice, data, multimedia. It has faster web browsing, okay? You can have also video call. You can have TV streaming also with limited, although with limited speed. Then we had the 3.5, and then we have the 4G, which was a very big evolution in telecommunication and mobile internet. Here we have higher speeds, we have high quality voice over IP for communicating or for making telephone calls. We managed to get HD or high definition multimedia streaming, 3D gaming, HD video, and so on. Now the 5G is now available in many places, and here alhamdulillah and mashallah, we have very good technology. 5G is there everywhere, and it's provided by the big telecom companies. They provide speeds up to 10 gigabits per second and maybe more. They are super fast mobile internet with low latency, and they are very adaptive to IoT, or the Internet of Things, okay? They can be used for security surveillance, for multimedia streaming, autonomous driving, electric cars. Now let us talk about some of the emerging technologies, or technologies, let's say. I mean, I cannot say that they are very new because some of them are already there, but how they are beneficial to us, okay? We have the virtualization, we have PPL, and we have blended. Virtualization is increasingly used in learning, in research, and assessments. Most of universities, they teach some of their subjects, computer subjects, and some of the engineering subjects using virtual machines. Nowadays, especially after the Corona, we started to hear a lot about virtualization and how they are beneficial to us. I'll give you an example. You can have one computer lab where the students will just bring their laptop, connect to the cloud, and they can open their virtual machine in the cloud and do their work on their virtual machine in the cloud. After they finish, they can save. Their teacher can access these machines, can see and evaluate what they have done. They have completed the task. If it's an exam, a practical exam, the lecturer can check and mark these virtual machines. Okay, so this is a huge benefit, and it's a good facilitation method for teaching and for evaluation of learning. Some of the topics, some of the departments that are already using that is computer engineering, computer science, They use it for security courses, digital forensics, their ethical hacking courses, penetration testing techniques. Okay. We have different kind of virtualization. We have, one of the big ones is Hyper-V or VMware. Okay. And you can have virtualization, and you can integrate the virtualization with the cloud. This will give you huge benefits. Now, we don't have time, to go and talk more about this feature, which is virtualization and cloud together, but it is there. It is being used now. The second method is problem-based learning. Here, the students, they are given an open-ended question. They are asked to analyze and to virtualize cyber threats of an IoT devices used in smart grid and smart home, for example, or they are asked to, this is just an example, or they are asked to solve a problem, maybe after talking, maybe like they are given a task or a challenge that the industry needs to be solved. So they are given this as part of their learning journey. They are given a question, real life question that they need to solve. And just we have to notice here that this is an open-ended question. So they need to do some work. They need to prepare themselves. They need to, as we will talk here, they need to follow some certain steps in order to be able to do this task. And this task, for example, as I mentioned here, maybe to analyze and virtualize a cyber threat of a smart home or for the smart grid. Okay. Now, blended learning is a wide term used to label the combination of face-to-face innovation learning and online delivery of teaching and learning. That's why it's called a blended. Now let's go and talk about what the millennial prefer or what do they need. Okay. If we look about what do they need from their boss. Millennial think about his future work, that he will be working in one of the top 5 companies. That's their ambition. And they are looking to find a company that is flexible, giving them flexible hours, comfortable working hours, and comfortable environment. They need from their company also that it will develop their skills while they are working. They are looking for a company that have strong values, and they are a company that is offering customizable options in the benefits, in the reward package, even in working hours, as I mentioned before. And also that allows them to blend work with other with the rest of life. Yani it's their life, they will not be just dedicated to work, or they want to enjoy their life while they are doing their work. Now, we also want to know and this is more important to us, what do they need from their teaching institution or their learning method, or from their learners. They need their institution to be one of the top 5. Okay. They need it to be a high-ranking institution, if possible. Okay. And by the way, these are coming from some statistics, and we just put only the high-ranking, the top reasons for each, or 5 reasons for each category. So they need also, they need to be able to learn technical skills, hands-on. That's why the applied education is more popular now. Okay, they need to be able to manage their time. So self-management and personal productivity. They need to learn leadership while they are learning. And they need also to be able to, they need to be able to communicate with industry or have some sort of engagement with industry. And as you can, I mean, nowadays it is part of most institutions, they will have like a department or a unit that is doing some engagement with the industry. In some places, they call them industry engagement. Okay. Also, the learners or their learning institution or the college or university should be using creativity and innovation strategies. Okay. Now let's talk. Let me here show you what are the. I mean, in nutshell, what is the difference between passive and PPL learning? In the traditional learning, we call it passive because it's most of the time it is one way. The students are told what they need to know, what are the course objectives or the learning outcomes. Most of it or some part of it is they need to memorize some of the information. And then they are given a problem or a quiz to illustrate and to prove that they know how to do this, or they have learned, and they are evaluated by giving them a problem, and they are able to solve it. Then they are given the mark. However, in the problem-based learning, the problem is assigned. Actually, before the problem assignment, there is some preparation for that. And this preparation is part of it is done by the lecturer, okay, or the professor. So the problem is assigned. The students will identify with their teacher what are the things that they need to know or the skills that they need to build in order to be able to tackle this problem. Then they will learn and apply this knowledge and skills to solve the problem. Okay. So here we have the students are given open-ended question, for example, to analyze and this is just an example for that, to analyze and virtualize cyber threats of IoT devices used in smart grid and smart homes. And they are to follow these steps while they are mentored by their teachers. Nowadays, by the way, if we want to discuss how this can be integrated with the engineering body or the engineering, for example, with the engineering institutions. So we need to know what are their criteria for engineers, and we are focusing here about engineering just as an example, but this can apply to CIS also and to other curriculums. EBIT, for example, they look for an ability to design and conduct experiments, as well as to analyze and interpret data. Okay, this is the Australian criteria for engineers. They are the students or the graduates should have an ability to design a system, component, or process to meet the desired needs within a realistic constraints such as economic environmental, ethical, and so on. They should be able to function on multidisciplinary teams. And they should be able to they should have an understanding of professional and ethical responsibility. And they should be able to communicate professionally and effectively. Okay, and the rest of them. The last one is very important to me. That's why also I would like to stress on it, is their ability to apply knowledge of what they are learning, math or science or business or computer or engineering, to apply the knowledge of what they are learning. In the Australian Institute criteria for engineering or for engineers, they should be ethically conduct and professional accountability, effective oral and written communication. Again, you see how that's why in problem-based learning we are working in teams. Professional use and management of information, orderly management of self and professional conduct, effective team membership and team leadership. You see how we are again. Why I am mentioning this, because you will find that how these attributes, they can be enriched and enhanced using the problem-based learning, whether the American previous one, the American engineering criteria, or the Australian attributes, okay, for the engineers. So let us talk about some features of the problem-based learning, and you will see here how they are matching even more of what is required by those institutions. The problems, they are designed to emulate real-world problems. Actually, the teachers or the institute, they are meeting with industry, and they ask them, what are problems that you are really, or you are looking forward us to help you solve? Okay. Problems used are complex and cover multiple objectives. The problem or task is introduced first before any learning occurs. So that's the first step. Okay. Learning procedures, facts, and concepts occurs within the context of finding a solution to the problem. So the objective is to find a solution to the problem, but the journey is rich. There is learning, there is analysis, there is communication skills. Then we have specific procedures or algorithms are learned as needed to solve this problem. So the student maybe need to learn, let's say, programming skill, needs to learn maybe how to create objects, or need to do some advanced Python learning, programming. So these skills are built in order to be able to solve the problem whenever it's needed. Additional structure for learning is proportional to the experience level of the learner. Some students, they have more skills than others, so we have to also be able to deal with that. So some students, they might need some advanced learning. Some of them, they might need medium level learning skills, or low or normal media level skills. So we can customize the learning experience according to the learner needs. And when this learning is happening, it's actually communication between the professor or the mentor and the students. So they have some deep questions, open-ended questions, collaboration, meeting with the team, and encouraging them and follow up with them to make sure that they are in the right learning path. Okay. And this is all done in a collaborative environment, okay? Now, why is this important? This is important because the world now is facing a problem with the graduates, that some graduates, they are not finding the right job, or the employers are not finding the skills they need in the graduates. I'm talking about generally about just a world statement, okay? Not talking about any specific region or, okay. Now I have seen in one of the statistics, okay, that only 7%, only 7% of engineering graduates are employable, and this was done by a study, and very professional study, extensive employability focused study on 150,000 engineering students. And this was published by the world's leading assessment company in India. Okay, and they have some operators in the US and Europe. So it's like almost half of the world. Okay. And the reasons for that, these students are not employable. Guess what? It's not that they don't have enough skills, technical skills. No. One of the main reasons is they are not having adequate communication skills, and they lack ability to apply the concept that they have learned, okay, to what they need to do. That's, yeah, they are learning the theory, they make good marks in theory, but they need to learn how to apply this to solve real life scenarios, okay? If we need to know in our study, need to know what is the impact of this PPL, we have asked 2 questions to the employers, and we have done this survey to find out what our employers are looking for. We asked them, what are the most important characteristics that you are looking for when you are hiring graduates, fresh graduates, engineering or computer graduates, for example? And then, do you think that problem-based learning will improve their skills, will improve their chances that they get hired by you? And these are our findings. I hope I have enough time to, yeah. Let's just go over the top ones. Okay. The top one was, again, the most characteristics that they are looking for, the employer is looking for. It's not only the technical skills of what you know. No, it is about how you can communicate. So it's communication skills, how you can communicate, okay? And also subject understanding, of course, it is important, but it is about how you can ask questions, how you can give information, how you can collaborate with team. Then they look for higher grades. They look for personality, professional personality, and also some of the important things are the applicants are aware of what's going around them. They are up to date with their knowledge, okay? And they should have some research experience. It came up like 5% only, okay? But it really depends on the position. If you are applying for a scholar, maybe research assistant, then of course they will ask for more research experience. Now, when we ask them about problem-based learning, the employers, they were really very, the employers' response was very encouraging to us. 88%, they said yes. They were very supportive. At least this is what they said. Okay. Only 5%, only 7% said no, and 5%, I mean, they were not sure, or maybe they didn't know exactly what is PPL. Now here we have some examples of PPL in some of the top universities of the world. By the way, let me tell you something. Considering the importance of PPL, UNESCO, they have a chair in PPL, learning in education, in engineering, and in education since 2007. They know how important it is. Okay. In Aalborg University in Denmark, they are one of the leading universities. They collaborated with UNESCO, and they use PPL as a methodology in all their programs. Okay, and they have even a master degree in problem-based learning. Okay, to teach educators to be master in PPL. We have also in Australia, Central Queensland University. It is Australia leading destination for engineering education, and it has adopted, I mean, they have a very top rank, I mean, one of the top universities in the world. They have adopted PPL, and they have done cooperative industry internships for this. So as you can see, PPL is there. They are adding some tools to it. They are collaborating with industry. The PPL focus in CQU, they focus on building student skills, communication skills, teamwork, collaboration, problem solving skills. Okay, while they are learning, the students are learning the skills they need to solve these problems, and while they are learning the ethics of the profession they are being taught to become. Okay. Victoria University, I mean, I had chance to visit this place in Melbourne. They are already adopting the problem-based learning, and they call this the cubicles. They call this place the cubicles. So each team is given a cubicle where they work, where they are assigned a problem, and they are working together with the supervision of their teacher or lecturer to solve these problems. Okay. Sometimes they call them also studios. So yeah, I remember we were calling them cubicles. By the way, now in Victoria Uni, they are teaching PPL for some of the courses in year 1 and year 2, as I know. So in conclusion, PPL should be integrated in the syllabus of the subject. So you should integrate PPL in the technical courses, in the academic courses, okay? And this can be done, this is before this is by getting also with getting the feedback from the deans, from the industry, and from the students themselves. So after the syllabus is built, the problem-based learning can have a better implementation. We cannot just throw a question and do it like, okay, this is your, like an assignment. This PPL is an assignment. No. In my opinion, the best way to do it is that it is integrated in the syllabus. So it is thought about while you are building your syllabus that, okay, we will have PPL as our method of learning. Okay. And of course, for PPL, we need the support from industry, from instructors, students, and facilitators. Okay. And thank you very much. And I look forward, if you have any question, please let me know. Okay. Stop my sharing. Any questions, please? Okay. Let's see if we have any question in the chat. Thank you. You can take the mic and talk if you have a question, or you can just type your question in the Q&A. Okay.
Okay, thank you, Doctor, for your great presentation. Such a great topic. It was very interesting, and I think there's no questions right now. So thank you so much, Doctor.
You are mostly welcome. Thank you, and good luck. Have a nice day, everyone. Thank you.